Now we consider the case mass spring dashpot system. So before we did consider mass spring system without the dashpot. So we don't have the C term. Here we have the spring with the constant K. We have our mass M and the dashpot C. So the ODE we have is mx double prime plus c x prime plus kx equal to ft. Ft is the external force. So in our case, it is a periodic function, a period to L. And in this example, I consider the case f is odd. We can do similarly for f is even, or even we don't even need that condition. We can do Fourier series for the full Fourier series. But to make it simple, I do it for odd function. Now we write down the Fourier series for f. The Fourier series of f ft equal to, because f is odd, so we have summation with only sine terms, bn sine n pi t over L, n from 1 to infinity. Bn can be determined. This is 2 over L, 0 to L, ft sine n pi t over L dt. So this one we can compute this explicitly. And we need to solve this one equal to ft. So now let me just do by the superposition principle. Instead of looking at the whole summation here, I just look at one terms. So we consider mx double prime cx prime kx equal to just one terms. So just look at, say, f0, f0, sine omega t. So omega t. So instead of looking at this whole big thing, I just look at f0 sine something t, so sine omega t. And we know how to solve that. To solve this one, you need the solution. Xt, now we have two parts, the homogeneous part, complementary solution. xt plus x particular solution t, complementary function. Now comes from homogeneous part. And this is our particular solution. And in the case we have the dampers or the dashpots, C bigger than 0. This one will tend to 0 when times tend to infinity. So this will die out. X8t tend to 0 in case we have the dashpots C bigger than 0. And this part we call it the transient solution. It will die out eventually. Transient solution. So leaving only the particular solution, this part. And now we will try to get xp. Find xp. We use the methods of undetermined coefficient. So we let xp t equal to a cosine omega t, because it's this one, and we have x prime right here. We need also cosine omega t, b sine omega t. So what you do now is that you need to compute x prime. You need to compute x double prime. You plug in this equation. Say star, plug in star, and you equate. Let the coefficient of sine and cosine equal, and you find out a and b. X p prime t, you need to compute the derivative. You need to compute x double prime t, and you plug in star, get a equals something, b equal to something. And now from that AB, we will rewrite this sum from a cosine, b sine into the form only with sine. So this gives us something like this. Big F0, big F0 is our F0 right here. Big F0 over square root, so really big, k minus m omega square c omega square sine omega t minus alpha. So here we have alpha is arctan, c omega over k minus m omega square. So our alpha between 0 and pi. Yeah, so by doing all of this, we get xp equal to this form, and this is what we can use, xpt. We just use a form with sine terms. This is our xp for this equation star. We want to do that not only for just one term, but we have the summation of all those terms. So by the superposition principle, we can get all of those. So superposition principle tells us that we have solution of this one, mx prime, mx double prime, cx prime, kx equal to ft equal to this thing. This one will give us solution x. We are talking about the particular solution, then we have steady periodic solution, x spt for this equation. So we have summation n from 1 to infinity, and with each term will be of this form. So instead of having f0 here, you have bn, sine of this, so sine of this minus alpha divided by this. So summation bn sine omega n, where our omega n, I call it this term, omega n, n pi over L, omega nt minus alpha n. So for each of these terms, we have one alpha n divided by square root. I copy all of this, square root of this one, and remember that this is for omega n, omega n. So So this is our formula. So we have a so big formula for the steady periodic solution. So I say here's by superposition principle. This is our steady periodic solution. This angle alpha n is determined by this formula. Omega n, alpha n. So this is the formula when we use Fourier series methods to find the steady periodic solution of this ODE.